Okay, power rules. To have power rules, you need to have power inside the parentheses, or an exponent inside the parentheses, and outside the parentheses. Okay, so let's look at an example. Here would be something with a power rule. 2x to the 4th, y to the 6th, to the 3rd power. You see, this is powers inside and powers outside. I call the power rules power to power because it expresses the idea of the power inside and the power outside. So the power to power rules requires the multiplication of the exponents. Okay, so let's look at this one. This example that I just gave you has 2x to the 4th, y to the 6th, to the 3rd power. This means the power I do not have listed is the power on the number 2. So I have 2 to the 1st power. Therefore, my power to power says this power multiplies the power that is outside the exponents, outside the parentheses. So I've got 2 to the 1 times 3, which is 3. And then x to the 4 times 3, which is x to the 12th, and y to the 6 times 3, which is 18. Notice that that outside exponent applies to everything inside the parentheses. So why is this true? Well, remember what the definition of exponent says? This says this whole thing is the base, that base is used as a factor 3 times, okay? So we're going to write it down. X to the 4th, y to the 6th, and 2x to the 4th, y to the 6th. All right? So notice 2 times 2 times 2 is 2 to the 3rd power. X to the 4th, x to the 4th, x to the 4th, all the same base. So this is 4 plus 4 plus 4, which gives me x to the 12th power. And my last one, y to the 6th times y to the 6th times y to the 6th. So this is going to be y to the 6th plus 6 plus 6, which is 18. And this is why the power to power uses that multiplication. It's because the whole base is being repeated that number of times, and the multiplication is nothing more than fast addition. And so you're going to multiply. We'll go ahead and finish 2 to the 3rd is going to be 2 times 2 times 2, which is 8, x to the 12th, and y to the 18th. So you can see how that works. Now let's look at another example. What if it's a fraction that has been taken to that power? So let's start with a simple one. 1/2 to the 3rd power. This means 1/2 times 1/2 times 1/2, which would be 1 times 1 times 1, which is 1, 2 times 2 times 2, which is 8. Applying the power to power, this becomes 1 to the 3rd power over 2 to the 3rd power, because it's the first 1 times 3 is 3, and 1 times 3 is 3. Well, 1 to the 3rd power is 1, and 2 times 2 times 2 is 8. So there's 1 with a fraction. Now let's make the fraction a little more complex. Okay, let's look at it. 2x to the 3rd over y to the fourth. And let's make this to the third power. Okay? So, using our power to power, my 2 has an exponent of 1, so this gives me 2 to the 1 times 3, which is 3, x to the 3 times 3, which is 9th power, and y to the 4 times 3, which is the 12th power. The only other simplification we can do on this is to go 2 times 2 times 2, which is 8, x to the 9th, and y to the 12th. Okay, so there you see the power rules that can be used as well. So now let's look, what happens when we become even more complex? Let's do one more that's a little more complex. Let's go, let's see, 3 to the 2nd power, x to the 4th power, y to the 5th power, over x to the negative 3 power, this whole thing to the negative 2 power, okay? Now, what we're going to do, we can either change that negative 2 to a positive power by doing the reciprocal of what's inside, which is what I'm going to do. So this is going to become 3 squared, x to the 4th, y to the 5th, and x to the negative 3 comes on top. And now this is to the positive 2 power, because in doing the reciprocal, we have now eliminated the negative exponent. So now let's apply our power rule. So this will be x to the negative 3 times 2, which is negative 6, 3 to the 2 times 2, which is 4th, x to the 4 times 2, which is 8, and y to the 5 times 2, which is 10. Now, notice I have a negative exponent up here. I can make that a positive exponent by flipping it down to the denominator. So this is going to be 1 on top over 3 to the 4th power, which is 81, and I now have x to the 6th, x to the 8th, and y to the 10th, which is going to equal 1 over 81 times x to the 14th and y to the 10th. So you can see that we can put all the rules together and use them in that way. So there's a lot to it. The last thing I'm going to do is give you one possible order of operations for exponents. And that's going to be the next video.